It's been a real pleasure for me to participate in this weekend event and an eye-opener. I have a grandson who's PKU, and I'd like to acknowledge, my son that you guys know as Mike. We always, as a parent, call him Michael. Michael Franklin, who's 11 years ago called us and told us, we've got this issue with Ethan. It looks like he's PKU, and of course, even both of us were in the medical profession, but it's like, well, what's PKU? So you get on the internet and you do all those things and find all this crazy stuff and get all bent out of shape. And but I have to say that Michael and his wife Amy have done a great job with Ethan. He's an 11-year-old that participates in kid marathons. He runs and bikes and swims and plays the violin and the piano. And Michael tells us he's the best controlled P kid in all of Indiana. So they're pretty anal retentive about that, too. And as you can imagine, as we had some of our first visits with them, and particularly when Ethan stayed with us for the first time, it's like this 3-page list of do's and don'ts, And then making sure that when you mix and pour the formula that you don't act like it smells bad because he doesn't know the difference. So we've learned a lot over the last 11 years, and it was interesting in doing that first. I guess it was a Medline search back 11 years ago, but just a couple weeks ago I did a PubMed search on hepatocyte transplantations in PKU, and I got 290 hits. So things have moved a long way in 10 years, and hopefully in another 10 years we're going to have another major step. I'd also like to thank Dick for inviting me to participate as a part of the Scientific Advisory Board. And then we've got a great group of folks participating there. Emil Kakas, who can't be here, and Harvey Levy and Catherine Mosley, who's here, and also Ray Stevens, who's here. So they've been very helpful in making us put together a process that was very critical and very detailed in how we evaluated our applications for the postdoc fellowship that we awarded yesterday and our 2 research grants. And hopefully as our funding increases, we'll be able to do more of that and get the word out to more people. We were on sort of a short timeline this year, starting things in September and getting decisions made by the 1st of January. So hopefully we'll have a little bit more time next year and get the word out to more metabolic centers and have more applications in. And I'd also like to thank Christine. I've been a nonprofit executive director and president for 21 years of my prior life, and so I know what it's like to organize and get things going in a nonprofit mode. And you guys have a winner in Christine. She's very good. Well, let's move on to our medical advancements in PKU, and we've got 3 very interesting speakers today. Our first one, Rani Singh, most of you know. Dr. Singh is an associate professor of human genetics and pediatrics and the director of genetic metabolic nutrition program at Emory University in Atlanta. You've got a detailed bio in your booklet, I think, on Rani. But she's the PI of the HRSA MCHB funded project, Enhanced Genetic Services and Newborn Screening Collaborative in Region 3. And she told me yesterday there are actually 7 of these. Is that right, Ron? There's 7 regions around the country that have these sorts of HRSA programs. That's the Health Resources and Service Administration, and it's done through the Maternal Child and Health Bureau of that organization. She has 18 years of research and clinical experience in the field of inborn errors of metabolism, including the development of a model clinic for the management of IEMs. She's a member of numerous professional societies. She currently serves on the board of the Society of Inherited Metabolic Disorders and is president-elect of the Southeastern Regional Genetics Group. And for the past 15 years, she's been the director of the annual research-based Emory Metabolic Camp, helping adolescents and adult women with compliance prior to and during pregnancy. So it's my honor to present Dr. Singh to you to tell us about clinical nutrition issues. Rani.
Thank you very much. I want to start off by thanking the organizers for putting such a great meeting and also allowing me to be a part of this. I feel very honored to be part of this meeting and to meet many of you. So I'll start off by talking about the task I was assigned to talk about the critical issues in nutritional management. So it was a challenge for me to try to see in 25 minutes how to communicate all the field I'm so passionate about, how I'm going to talk about all this. So, but anyway, I decided I'll talk a little bit about medical foods, talk about the major nutrients, protein, and you heard very nice explanations from Dr. Nay and Lori in her session, but I'll reinforce some of the concepts and our experience with QN. Then I'll talk about carbohydrates and particularly share some data about the body weight. Then the last, fats, and talk about our observations with essential fatty acid. And finally, just mention some preliminary analysis on vitamins and minerals and some of the preliminary data. Actually, I just did 2 days ago on the bone density status, and which probably you'll be hearing more later from Heather also. So just reinforcing the pathway we talked about yesterday in terms of phenylalanine being the essential amino acid, which you all know essential means that our body cannot make it, so we have to get it from the diet. And in a normal diet, people would get it from the meats, eggs, and the diet coats, which have aspartame in it, which you all know, a big no-no. And the amino, this essential amino acid, is absolutely needed for normal growth and development. So we need it. We cannot do without this. And some of it is excreted in small phenylketones in normal metabolism. But most of the phenylalanine we consume is converted using the enzyme phenylalanine hydroxylate in the presence of BH4 to tyrosine, you heard. But I want to remind that tyrosine is also needed for protein synthesis. It becomes an essential amino acid in the absence of phenylalanine. So it is equally required for protein synthesis. And tyrosine is also a precursor of neurotransmitters, you heard yesterday. So how they affect the brain is very, very critical. So what happens in PKU, you heard yesterday very elegantly, that the PH enzyme, with the different over 600 mutations now known, gets blocked and the phenylalanine builds up. And what does that do when that phenylalanine builds up? It results in lowering of tyrosine and the lowering of the neurotransmitters in the brain, and also results in lower protein synthesis. And that's the connection between low tyrosine and accumulated phenylalanine resulting in low protein synthesis is very important. So not just the high Phe levels. How does it affect the body? So traditional treatment, as you all heard, has been using medical foods which do not have phenylalanine in it, combined with the phenylalanine from your plasma, along with the amount of intact protein, depending on the mutations you're carrying, and the two together work to do protein synthesis in the body. So the more medical food you drink, it sucks phenylalanine out of the system to combine with it to make the complete protein in order to do the protein synthesis. And the only other way we get phenylalanine in our blood is through protein. You would hear the clinician use the word catabolism, which means when we do not eat enough energy, our body starts breaking down carbohydrates and fats and the muscles in our body. And the muscle breakdown is seen like a piece of meat in the body, and the body doesn't know any difference. So the phenylalanine levels, that's why when some of you get sick, your clinics may say your amino acids are going to show high Phe levels. That's the reason. If you don't eat, taking enough calories during sickness becomes even more critical, because we want to keep the system from being catabolic, is the term. So once you heard that most of our diet in the classical PKU can be allowed as little as you heard yesterday, 150 to 200 milligrams of phenylalanine a day. And if we just had to use natural foods, you would see, this is from Helen McCune, a slide given to me, says it all. For 1/3 of your meal, you will just get this is what the plate would look like. But thanks to the advent of technology and companies like Cambrook who have developed wonderful foods, and we can extend and make a plate look very good. But still, the point is, we are depending on medical foods for our nutrients. I mean, that's the point which was made over and over again yesterday. This is a picture of one of the young ladies who may be in the audience. It is borrowed. And Elena gave this picture to me. And I don't think you need to be reminded of this, that the diet, despite our hard work and low-protein foods, it is still highly restrictive. It's challenging. It can be, you heard, it can be socially and financially burdensome, the reimbursement of medical foods and low-protein foods. We heard all that. It's time-consuming to manage. It's medical low-protein foods are unpalatable to some. How many moms try recipe after recipe and come back and say, I do it, I like it, but my child doesn't end up eating it. Or the adults who were never introduced to this are having problems incorporating in their diets because they were never introduced low-protein foods when they were young. So it's very difficult for them to have. And then so all this leads to problems with adherence. And we have talked about what lack of adherence does. There's a lot of literature right now indicating what the lack of adherence does. And this is some of the data just basically from some very recent papers showing that it results in low protein intake, low tyrosine intake, low minerals and vitamins, low essential fats in the diets, and also with this, the ratio of synthetic protein increases and the carbohydrates usually increase. When the PKU population is not consuming their formula, they end up filling themselves a lot with very, very high carbohydrate foods. But you probably cannot read the references I have put down. Majority of this work has been done in Europe and not in U.S. Recent work. I know after Dr. Koch and all, they published quite a bit when they were doing the collaborative study, but since then, things have been slowed down. Some of the nutritional work is going abroad. More of the work is being done. So we wanted to take advantage. The QVAN, we were going to enroll our patients for the QVAN trial, and we got an investigator-initiated protocol. So we have enrolled about 58 patients in the trial, and we plan to follow both the responders and the non-responders. So just to give you an idea, where we have both males and females, the patients are 5-year and older, and mainly Caucasian. So what did we find in terms of adherence? We were hoping, I always took a lot of pride in the hours I've spent in clinic, saying that I wanted to check out what our patients look like, the profile. And guess what I found? 48, these are now older patients, 5 and older. Half of our patients are non-compliant. 28% have phenylalanine between 360 to 600 micromoles, which is the same thing between 6 to 10 milligram percent. And only 1/4 of the patients are between 2 and 6, which is what we feel where we need to maintain in order to have good outcomes. And this data of 73% or 76% non-compliant is no different than the one published by Walter in 2004. So very similar profiles. It was not a surprise, but a little disappointment that we are still not getting the message out or doing the things to increase adherence to the diet. Next, we wanted to see what is the actual intake? We hear about it, that this is what's going on in the general population. So I took the data from the camp for the girls who come in 12 and older in 2004 and 2005 and tried to evaluate how do they compare to the general population in U.S. And what was interesting was the protein intake was still 15%, like in the Haynes data survey, which is the national largest data survey in U.S. The difference is that the 80% of the protein, like you heard yesterday, does come from medical food. So it becomes very important that we know what medical food you are consuming or you are giving to your child or your grandchild. It's very, very important to be educated in that. So what about medical foods? Now we know there are over 30 or 40 medical foods available in the market, and we saw some wonderful representations by different companies. They are medical foods which are complete, which have amino acids, which is protein, has carbohydrates, fats, vitamins, and minerals. They are, and I've just listed few. Please don't take it personally if your formula is not on this list. The amino acids with carbohydrate, the protein and carbohydrates, they are formulas just with protein and carbohydrates, and they're formulas with just amino acids. Now, why is it important? I'll show you that, but again, it's not only the composition. They are in different forms available now to try to improve adherence. They are in the form of bars, they're in the form of add-ins, they are in the form of capsules and tablets, just trying to improve adherence, and yet we have not seen. There are 2 points I want to make with this. One, it's not the quantity of protein which makes a difference. It is also the quality of protein. It could be intact protein. If it's incomplete protein, does not have essential amino acids, that's going to be utilized very differently than the one which is complete. The amino acids are going to be utilized very differently than the intact protein. So there's a difference, and we have no data in this country to understand those differences. The second point I want to make is medical food is not a drug. So it does not go through the rigor trials by FDA, which are expected out of a drug for the clinical trials to understand the impact on nutritional status and growth, particularly for children 1 year and older. So what we have to make the decisions about medical foods is based on our knowledge of biochemistry, physiology, and nutrition to try to do the best we can. And I know the companies are doing their best to try to bring you the best product. But nevertheless, we need to put more sciences behind that. Okay. So even though we don't have any clinical trials, I think we can try to learn by what has been happening in terms of the amount of protein. One of the questions which we asked are, and we don't have any guidelines in U.S. right now, how much protein do we need to prescribe in terms of the medical food? We don't have clinical studies to show that, but we do have some epidemiological data in the publications. And this is a complicated slide, but only thing I want to point out to you, what the message it gives is, there is data here which shows that in U.S., the protein, when given from 2.5 to 3.5 grams of protein a day, the Z-scores, and let me explain what Z-scores are. Z-score is a score which you compare of a PKU mean of the intake of the PKU children compared to the normal mean of the population. So the positive the Z-score, the better it is. And so here, the growth is much better when the protein intake was higher than what is recommended, or the DRIs, or daily recommended intakes of average Americans. So when we are giving protein in the form of synthetic form, we know that we see much better growth when we give much higher protein than what is recommended. And the countries in France, Netherlands, Austria, where the protein was given between 1.2 to 2.1, the growth was not as well. So there's something we can learn from putting this data together. I know it's one slide, but this is about 10 articles I've put here together to show you the amount of protein which is needed. The next thing I wanted to see was something we could learn from. This is an old paper in '98, and what this study did was try to look at the nitrogen of the protein, how much it can be utilized when the protein is given by itself, like an amino acid, when it's given with sugar or sucrose, or versus when it's given with fat. How does the protein synthesis occur, or when it is maximum? And what we saw in this data, a very simple study, that protein, when taken with carbohydrates, resulted in the best protein synthesis. And the reason for that could be that the carbohydrates, along with protein, stimulate insulin, which results in much more anabolic pathways of protein synthesis. But we need to work on this more. But the point I want to make is that there is a difference when you take just an amino acid mixture by itself versus when it's in combination with other products. Okay. Another paper which we could learn something from, this is very exciting paper. And what this study did was try to look at the leucine balance, which is a marker for how the protein is being deposited in the body. And what they looked at is the comparison between amino acid and casein. Casein is your milk protein. And of course, it's not a surprise that when casein was given in the same amount, that it was stored much better than compared to amino acids. But also what they did was they took the whey protein, which you have been hearing about, and compared it by giving 1 dose a day versus giving several doses during the day. And guess what? You see a huge peak in protein synthesis when it's giving multiple times a day. And I know we in our clinics have made these clinical observations to say that you need to be taking your formula 3-4 times a day based on normal physiology, that you will have better Phe control and better protein and better muscle mass in your body. So this is not a surprise, but it further scientifically confirms that that we continue to do this. I think it's very important, while we have a quest for future cures and technology, that we make sure that today we give the best care to our children and adults who need it today in the best form, so we don't lose on that time for this generation. So I think learning from what has already been done is equally valuable here. Okay. So while I talk about increased protein intake, protein restriction can be equally harmful. And these are examples from my own clinic for the patients. And they're not necessarily all PKU patients. One is MSUD, and the non-intake of protein restriction could be due to several reasons. Either one patient had developed cancer in addition to MSUD and could not eat, but nevertheless, we found it was associated with either a single amino acid over-restricted, like isoleucine deficiency in MSUD, or arginine deficiency in urea cycle. But also, this patient was referred to us with almost no hair from another state. And her protein formula had been cut off, and when we introduced in 3 months, this is how she looked like. And we could not really get our handle on whether it was a certain nutrient which was leading to this or whether it was the protein deficiency, because she was deficient in both. And it's not uncommon for us to hear when the patients are put back on the formula, when they've been off diet, they see as little hair loss initially, and then it starts coming back. So we need to kind of do further work in this area to try to understand which minerals, vitamins, and protein are leading to this kind of effect. Okay, so the first conclusions about this data are that the medical food should contain all nutrients in addition to amino acids, fat, carbohydrates, minerals, and vitamins. Or if you're going to take modular formulas, make sure you work closely with the clinician to ensure that your other nutrient needs are being met. You demand that from your dietitians to help you, or the physician you're working with, to evaluate either through your blood work and through your diet analysis that you want to be looking at that. The total protein intakes are much higher in protein. I am convinced we do need to do more work, but I can assure you that you do need more than DRIs. I can tell you with 15 years of my clinical experience, you need higher protein. And all the medical foods should be ingested more frequently, at least 3 to 4 times a day. And diet analysis should be done to assess all nutrients, not just phenylalanine. I know Lori emphasized this point in her workshop yesterday. I was shocked at the first GMDI meeting when I told the dietitians to raise their hand how many of them analyze the diets of their patients for completeness, not just phenylalanine content, but to look at all the nutrients. I only had 4 hands go up. And I think it's very important to allow times that the clinics hire adequate dietitians to give them the tools and the resources to analyze the diets and not just focus on the phenylalanine content in your diet. Okay. So in the literature, we also found that typical diets contain 75 to 90% of total protein. But recently, just 3-4 years ago, we found that the literature, there were papers saying natural protein was more correlated with muscle mass, and there was significant correlation with the head circumference. And the natural protein is, of course, based on your mutation and how much one can tolerate, but also on the amount of medical food you take. The adequate amount of medical food can result in higher tolerance of phenylalanine. So just during this time, BioMarin was coming out with the QVAN, and we thought perfect opportunity for us to try to answer this question. So we did a pilot study with QVAN trial where I had about 14 patients, and we looked at about 6, and we wanted to ask questions. Would the amount of intact protein go? In other words, at that time we didn't know how much Phe will they be able to tolerate? Will we be able to give them adequate nutrition? And how much intact protein would be increased, and how would that affect the nutrition status? I'm not going to be able to answer all these questions for you today, but I'll give you just a couple of glimpses what we saw. This is the 2 patients on QVAN, my first 2 patients. The first one had baseline of 510 milligrams of phenylalanine, and he increased by 1450, so ultimately 2,000 milligrams of Phe a day. The second patient I started was 250. He was classic. We didn't even think he would respond. But I decided, because we were being told it's only the mild one who are responding, I said, let's go try it. And we did, and he responded and got additional 1,600 milligrams of phenylalanine a day. So both of them are on 2,000 milligrams of phenylalanine now. So at the bottom, you will see my 6 patients who started at 418 milligrams of Phe baseline, had an average increase of 1,200, and my 6 patients are now around 1,600 or 1,800 milligrams of phenylalanine a day. And out of these 6 patients, I was able to remove 4 of them completely off medical food and was able to give. But I continued to follow them in our clinic. I followed them for 3 years. 2 years, we didn't have money for research, but we used the markers which are used for standard of care just to monitor and see how their growth is. And what is interesting is the prealbumin, which is a marker for short-term protein status, improved. Baseline, it was 19. At 1 and 2 years, they maintained it. Now, remember, I'm not giving them as high a protein. I'm giving them around 2,000 milligram, 40, 50, a little bit above the DRIs, and they're doing fine on this. And actually, because of the intact protein, I think their protein status has improved. And what was interesting was these are the Z-scores again, comparing with the normal. People will criticize me for not having a control group, but you can statistically use the normal population and compare how your patients responded. So this is the Z-score for the growth. And look at the growth. They have started to grow much better than they were growing before. Now, I'll warn you, this is just a pilot data. I'll report to you on our 58 patients in the future. But based on this, we have decided to do the study. And the lower graph shows their body mass index, which is a ratio of height to weight, was maintained. So we didn't make them tall and fat. They still maintained a very healthy proportion, I mean, that's one of the things we want to be sure that they attain their maximum growth. Okay. So our conclusions were basically BH4 is not a cure and long-term studies are needed, but in our big 58 patient trial, about 20 to 50% patients respond. In my pilot, 50% responded. In my overall, about 40% have responded. Some have better Phe control, so some of them had already liberalized their diet. So now we have brought them back to get their levels down to 10 and below. And some have increased Phe intolerance, and like I said, the Phe tolerance has varied anywhere from 250 to 1,000 milligrams a day. But most people are requiring some protein restriction. Initially, when the drug came out, one of the questions we used to ask was, will we be able to go to a steakhouse and eat a piece of steak? No. You still have to watch it, but it's a huge difference in quality of life not to have to. None of them are on low-protein foods anymore. And some of them continue on medical foods, some because they didn't respond without medical food, and I don't want to go there in terms of mechanisms. But for the girls, I have decided to leave them on 25% of their prescription. Because we don't know enough about maternal PKU and QVAN, I want the girls to have that option, and I don't want them to get out of the taste of drinking formula. So I do leave them on 25%. This was a personal clinical decision. I don't know if it's right or wrong, but that's what I'm doing in our clinic. Okay. And so Next thing I wanted to look at is the overall diet intake in these in our patients at baseline. What were they eating? And again, as it was brought yesterday, somebody had asked about carbohydrates. High carbohydrates in our PKU diet, 62%. Recommend. Oh, where's Sarah Foster? Sarah told me there's been no glitches in the audiovisual. Anyway, so the 62%, it's on the higher range of recommendations. The carbohydrates in a PKU diet consumption is around 62%. The fat consumption is on the lower side, and the protein consumption is about normal. So I think, okay. Wow. I get an extra minute, Susan, from your time. Okay. All right. Where are we? Okay. Next. It's not working. Okay. And so what do these high carbohydrates do? So we wanted to look at the weight, and I know I'm running a little behind, but it's about 10 years of camp data I have collected over time. We didn't have funding, but we used the clinical research facility, and we collect a little bit data every year. And about for 83 girls, we do the body composition and a bod pod where we look at the fat measurements and the muscle. And what we found that we were leaning the Z-score on the right side as the higher Z-score, that they were higher than the general population. We know obesity is an issue in U.S. anyway, but we are finding it's even more in the PKU population. And I want to bring out one point which needs further confirmation, and hopefully we can use some of the biomarine registry data to confirm, because my population is very small. Normal weight was equal in most of the girls, about the normal population. So the girls who are normal weight are about the same numbers, like in the normal population. There was overweight missing in PKU. So once they get overweight, they either go obese, we have a bimodal distribution, or what I found, some of them were underweight with some eating issues. And the eating issues, underweight, concerned me. There was 17% compared to 3.6% in the normal population. I had observed that at the camp with the older girls, but I was not sure, and the data showed that. And if we confirm these observations, this bimodal distribution, that at an adult, certainly even being on a lifelong chronic diet, I think we need to confront and address this issue if we see these patterns happening again, and try to have some discussions and help. So we saw either underweight or real overweight as adults. And again, these are adults which were told to get off diet early on. So hopefully this profile will change, but nevertheless, this is something we should keep up with. This is emphasizing that point. Sure. And also we found that the percentage of body fat was higher, about 5% higher in the PKU population than that. So again, I think it has to do with high carbohydrate intake and the calorie intake. And I don't have the time to report the details of the data, but what we found was that the high calorie intake was associated with carbonated beverages, sodas, and drinks, more than the food. Because it's a free food, it's a allowed food, it's something people can get up and socialize with friends, and the sodas can be attained. So we are not counting the calories, and it's underreported usually in the diet records also. So sodas was a big thing we found, and also when the low-protein snacks were given, the energy level is not being told how much to limit at. Because it's a free food, it's being consumed. But anyway, so the overweight status was much higher. And this is a small data just on girls. It's not girls and boys together. Also, it showed suggested higher prevalence of underweight in mature women, and the percent body fat was higher. Okay. Then we wanted to see that there are formulas with medical foods without fats and with fat So can the girls who are taking low-fat formulas, are they taking lesser calories? And we were surprised. I mean, anyway, the fat intake was definitely lower. In other words, when an adult was taking low-fat formula, here is the data. I'll go slowly. This is for under 18 girls and over 18 girls. Under 18 girls who were on formula with with fat, they were taking the recommended fats in their diets. The ones who were taking the formula without the fat, the medical foods without fat, their fat intake was lower, 22% and 19% below the recommended amounts. So they do not compensate with food. So they do not increase their foods to start adding more fat. So they do end up eating less fat, but that necessarily didn't mean they were taking less calories. They started eating more carbohydrates. So the weight was not a change. So I'm not sure how advantageous it is to go on a low. It's like I will take a Diet Coke and I'll eat my cheesecake with it. So it's more of a habit thing, you know. I feel I can cut where I can. But this raised another question in my mind about the importance of fat in our diets, the essential fatty acids. And what we looked at, I don't know, again, when we use the word essential, it means our body cannot make it and it has to be taken in the diet. And there's a lot of work coming out in the normal literature and the brain development and the relationship of DHA, which is one of the essential fats. It starts from linoleic acid, which are the good fats we eat, linoleic acid and linolenic acid, which are called, you must have heard the word omega-3 and omega-6. So omega-3 are the linolenic fats, which are converted in the body to EPA, which have a lot of functions in our body, and to DHA. And DHA has been associated quite a bit with brain development and the levels of DHA. In Alzheimer's, there's lots of NIH-funded trials going on right now. So we wanted to look at the DHA levels in our patient population. One of my doctoral students is doing a thesis on this, and what we found, and we are publishing these results, we found that the PKU patients have lower EPA and lower DHA levels in the plasma. And we are doing a double-blind randomized control trial to see how it affects the neuropsychological, and we'll be reporting those results at the SIMD meeting. So the essential fats were lower. So cutting on when you are taking low-fat formulas, make sure they have the essential fats. Now the question comes in, because the DHA in regular diet comes from fish and eggs, which are not allowed on a PKU diet, should we be giving preformed DHA to the PKU patients? I don't know the answer, what impact it would have, but it looks like it is definitely low, and we need to be doing something, and we can't wait. We need to be thinking more about it, the effect it can have, because in normal infants, it's clearly been shown to have a relationship with it. But the jury is still out there. Okay. So the other things we did with our 58 patients, this is the data I just literally got on Friday before coming for the Q1 trial we are doing. The good news is that, you know, all this data coming from Europe and the low minerals, and we did not see that much of it in our patients, which is a good thing because our formulas in U.S. are different. So one thing, a take-home lesson for all our clinicians is that most of the literature doesn't report what formula they were giving. Very, very little data is available on nutrient intakes. And it's important that our formulas in U.S. are different than what's being marketed in Europe, so we have to be careful when we are comparing. We did see, we saw good iron levels, good B6. We did see low B12 and low vitamin C in some of the patients. And I have to go back and try to figure out, is the B12 with the patients who are not drinking their formula, and the vitamin C, the ones who are not taking enough fruits and vegetables in their diet. But we'll be doing some further correlations, and I'll keep you guys posted as we analyze this data further. We found that by the way, I want to go back here, and I want to show the vitamin D levels were normal, and the calcium levels are normal too. In my previous population I did with the PKU girls, half of the girls had lower vitamin D levels, but this is younger population from 5 and older, and their levels were pretty normal, which I was surprised. I'm going to double check and send a blinded samples to another lab to be sure. But what we saw was there's a lot of discussion going on bone mineral density, the bones in PKU. We did the DEXA scan to take total bone density in all the PKU patients, and we found 33% of the patients have lower bone densities compared to 67%. Less than -1 Z-score, -1 to +1 clinically is considered normal. And so 33% of the patients, 58 patients who enrolled in the Cuban trial, have low bone density at the baseline. Okay? So this is very interesting data, what we saw, and it may be overwhelming, but I'm going to kind of point out, I did not see a clear relation between phenylalanine and bone density, other than in boys. We saw in boys, the higher the phenylalanine levels, the lower the bone density. So if you see the phenylalanine levels here at the bottom, so the higher the number, the lower. This line, anything lower is a bad score. In the girls, I did not find a correlation with the phenylalanine level. What does that mean? It means some other things are going on other than the Phe. It may be hormones, it may be vitamins, minerals, it could be other things we need to look at. What's going on. So gender effect was definitely there when I did it. But I just did this analysis 3 days ago. I have to do more thinking about it, but I did want to share with you that the bone density is lower in 1/3. And we've been talking, but we have not had much data in the U.S. to kind of show this. And here is the distribution. We found small amount of children already who were in 5 to 11 years of age having lower bone density. Not dangerous, but in the lower. And some of these are compliant patients, but I need to go and do some more analysis with that. The worst was teenagers, 12 to 18, young. And they are the one during the growth bone. So we need to really go back and make sure they're compliant, because that's the time when they start to get non-compliant. We need to look at their relation. Also need to look in the girls for the hormones and other things. Adults have a surprise. It was not, the mean was around 0.6, a lot of variation, and all subjects was 0.6. So it was not too bad. So you're not looking at osteopenia or bone breakage, because -1 to +1 is still clinically considered within the normal range. So they're on the lower normal side. So it's not like the PKUs are walking around with bone fractures and things, but it's something I don't know long term how it will have an impact. But we will, hopefully Heather will share some thoughts in how she will be evaluating all this. Okay? So in conclusions, plasma DHA concentrations are lower in PKU patients, and we are doing a double-blind randomized controlled intervention trial with DHA. We'll be reporting to you. And we also have found lower mineral bone density in patients compared to normal control. So our future research, we want to do systematic long-term outcome multicenter clinical trials to try to answer some of these questions. As you can see in one clinic, we may be able to enroll 50 to 60 patients, and when you start breaking them down into groups, it's not large enough. So I think one of the things, yesterday in the professional group, I said we should try to do through this organization is, as professionals get together and try to collaborate on doing some good multi-center trials to try to answer some of these questions which we have long waited for. So with that, I want to thank my team, particularly this research group. Sarah Yee has been working on the DHA trial. She's my doctoral student, and she'll be reporting her results and graduating this year. Teresa is doing also her doctoral thesis with me, and she'll be looking at the neuromarkers and the phenylalanine aspects of it. Mary Jane Kennedy, who's the research nurse coordinator, and the 2 registered dietitians who are on the research. The rest is the other clinical team with other projects we are doing. But I wanted to particularly thank, and I'm honored to be a part of High Hopes, and hope that we can continue to join hands to achieve the maximum potential for each and every little baby we pick up, and also the adults who are here to help them achieve the maximum potential. Thank you so much.